Trek. It's a journey that starts in the 1970s. The oil crisis is on. Gas is expensive and scarce, and the world starts to believe in the bicycle. But this bicycling boom has created a bicycle shortage. So Dick Burke does what problem solvers do. He sets out to build bikes, the best bikes in the world. It's 1976, and together with 5 employees, in a barn, they build a culture of craftsmanship. They miter, they braze, they build a business. They call it Trek. The bikes sell. People love the way they ride. It's a family business, and every customer becomes part of that family. The 80s. Change is everywhere. Where people ride, what people ride, it's another cycling boom. The world of bicycles is changing, fast. So Trek grows the family by adding engineers from outside cycling. Engineers who have built airplanes, and rockets, and spaceships. It's a culture of invention, for the road and for the mountain craze. Trek's new engineers evolve bonding frames together. First aluminum, then an emerging material, carbon fiber. Half the weight of steel, simple carbon threads, woven, bonded, molded, amazingly strong. They call it OCLV. It's the 90s, and Trek is awarded multiple patents for the first successful all-carbon frame. The bike world would never be the same. But the world still didn't believe a bike this light could ride so well or last very long. Trek had something to prove, and racing is the ultimate proving ground. And there is no bigger stage, no bigger test than the Tour de France. The race was on. It's 1999, the first Tour de France team to race exclusively on carbon frames. The start of a race resume greater than any modern brand. And a journey that has made Trek believe that they could do more than just create bikes that riders love. They could make bikes that win. Great athletes ride Trek. It's the Trek of today. Bikes lean on desks, lunchtime rides turn into lunchtime races, on the road and on the trail, Trek's very own trails. Trek has become a family of cyclists, for cyclists, road bikes, mountain bikes, urban bikes, worldwide, because it's a group of people that believe anything is possible and continue to prove it anywhere, while still handcrafting its fastest carbon frames in Waterloo, Wisconsin, where they still strive to build the best bikes in the world every day. It's the mission that Dick Burke launched in 1976, when the very first Trek was built, a Trek that is still under warranty, a promise the family made to its very first customer, and on every bike since. We believe in taking care of our customers, but also in all the things a bike can do. Battle climate change, lessen congestion, and improve health. It's transportation that brings us together, yet lets us escape to places we'd never see any other way. There are 1 billion bikes on this planet, which means 6 billion people aren't riding. We believe we've got more work to do. Trek, born in a barn, raised on rocket science, raced to win, warranted for life, loved the world over. Become part of our family. We believe in bikes.
So for 2013, the focus on the MTB group was on the Superfly and the Superfly 100, and we really wanted to make a significant change in that category, to come out with a bike that was the new benchmark in 29ers. And with that, we wanted to be the lightest possible bike in the category, but still have the ultimate in ride. And to take those two things and combine them, we came up with an all-new development, which is called Apollo.
We started out with brainstorms, going through and just listing all the ideas out there of how to make a lightweight product. And really, the team had one goal. It was a goal of making the lightest bike on the market. The project started in the advanced concept group and we really started working through different ideas and concepts.
We worked with a lot of different people from a lot of different areas. We wanted people from the road group who focused on the elimination of every last gram.
We went to all aspects in the company, to our carbon experts, to our manufacturing experts, and brought them all in together with our mountain bike development group to make sure that we didn't leave a stone unturned. And I think that's one piece that people forget, is that Trek is a manufacturer, and we've been a manufacturer for a very long time, and carbon fiber is definitely our specialty. And bringing them to the table early, they were actually able to give us ideas in a development group that allowed us to bring out even new manufacturing techniques and technologies that we never would have thought of before without having them there. You know, every idea, every thought, every blue sky concept was explored. We didn't really leave anything on the table. We did more prototyping, more investigating in this project than we ever have.
After the concept phase, everybody came together to start looking at how to move forward. One of the great things about our group is people aren't afraid to share their ideas. People aren't afraid to disagree with each other.
So testing with the Apollo development was key. I mean, that was really the biggest part of the project, to get to the different benchmarks that we had for the development. And a lot of the testing was done on trail, and I think that's the most important part of any of our projects. We, again, prototype more than we ever have on any project. I mean, at one time we had as many as 8 different types of prototypes out on the trail being ridden in different areas of the country, getting feedback on them. And one of our best assets is Travis Brown, and Travis Brown, former Olympic World Cup level racer, and also an incredible tester, very dialed into the feel of a bike, and very dialed into being able to relay what he's feeling in the bike back to our mountain bike development group.
You know, before this goes to production, I will have almost a year of riding the carbon fiber prototypes. Iterations are critical to this process. Giving ourselves the luxury of testing a frame and having enough people evaluate the characteristics of that frame, and then take a direction from that and reproduce a next generation, is the process that we refine and make things better in every step. And every time we have that opportunity to critique something, pick it apart, and ask for something new, the next generation's always better.
The end result, after 2 years and a new process, the Superfly and Superfly 100. The Superfly, the benchmark in weight and performance, at 896 grams, with an amazingly balanced and lightweight frame that's incredibly fast. In full suspension, it's the Superfly 100 at 1,650 grams, again amazingly light, but not only light, fast, balanced ride. That's the goal. So when you look at the products, the Superfly and the Superfly 100, you're going to see the 2 best bikes ever from Trek.
What we're trying to do here is optimize the experience on the trail and achieve the utmost ride quality out of the bike. You know, that doesn't happen by chance. It requires a lot of test time, a lot of time on the trail, a lot of tuning and then retuning. You know, ultimately, we have a lot of great tools that we use here, but at the end of the day, the most critical tool and the most valuable tool is the rider on the trail. DRCV stands for dual rate control valve. Dual rate means we actually have 2 air chambers in one, and the control valve is the plunger that controls when the second chamber comes into play. The first chamber, working solely on its own, is very similar to a small volume air canister up to that point, keeping it lively, keeping it responsive. When that plunger comes in contact and activates and the second chamber kicks in, both chambers are working in unison. In the return stroke, that plunger valve closes. Once that valve closes, the upper chamber stays at that pressure. You never feel a firmness. It's a very gradual slowdown. So it really is like having 2 shocks in one. Ultimately, the best way to see DRCV work, it's on the trail itself. What you're seeing here is a small canister air shock. Notice how it's handling the high frequency bumps fairly well. But when it gets to the big hit, the system is taxed and the shock doesn't fully compress, and the rear wheel kicks up upon return. With the extra volume canister air shock, it takes big hits and achieves full compression, but it has difficulty with the mid-stroke control and handling higher frequency small bumps. Now with DRCV, you get the small bump compliance and the big hit control. Notice how much the shock is really moving. The data acquisition shows the liveliness of the DRCV first stage. The chassis and the rider are isolated from the terrain. You can really see how much control that gives the rider. Here on a big hit, you can see the limitation of a small can. The shock uses all its stroke but cannot react effectively to the subsequent bumps. Instead, the rear wheel kicks up and the rider's control is compromised. The DRCV handles the big hit. The shock compresses fully and takes the force of the drop with ease. The data shows the shock's ability to handle multiple bumps following a big hit. That's the big difference with DRCV. It remains lively and active all the time. With the extra volume shock, the rider comes into turn with great control. But halfway through, the stutter bumps start to overwhelm the shock. Packing it up, the back wheel loses traction. As the bike with DRCV rounds a turn, watch the back wheel trace every single bump. The shock doesn't pack up. The data shows every bump being absorbed no matter the frequency. This lets the rider go faster and stay in complete control. It's not about more, it's about doing more with what you've got. Now you understand how DRCV really is 2 shocks in one.
riding out on the dusty road. The sky's blue and my t-shirt's torn. Up on the hill I found my thrill, and down in the valley I got my fill.
Every time you start a new pedal stroke, there's a delay before you actually start moving. This dead zone can cause you to lose a lot of ground or completely ruin your ride if caught in the wrong situation. Known as free play, this lag measures up to 15 degrees with a standard hub, and that translates into lost ground, up to 4 inches with 29-inch wheels. Bontrager's new Rapid Drive technology uses a fast engagement hub mechanism to engage quicker and provide up to 2 extra inches of forward progress. Immediate, efficient power transfer.
I think wheels are, apart from the frame, they are the most critical component to the overall ride, feel, quality of the bike itself. And when you improve the quality of the wheel, you improve the quality of the ride. Wheel building is still an art. No matter how many controls you put in place, you still need to have experience and craftsmanship to ultimately build a better wheel. It's when you can't really tell where technology stops and the human element begins. I mean, that's where all the good stuff happens. An aerodynamic wheel will make you faster. The data doesn't lie. You can actually feel the wheel propel you forward. That's what it is doing for you. This was years of development that took us to get to the place where we are today. We are the supplier to the world's fastest bikes, and we make those fast bikes even faster. You want your wheels to have a good feel to them, and you want them to last over time. So they need to be able to corner hard and hold up to the pounding of cobbles or the hits on a downhill run. Our wheels are going through hundreds of thousands of cycles of testing before they ever see the bike of a rider. We are North America's only independently certified UCI test facility, which gives us a huge advantage in that we can develop things faster, get them to our race teams quicker. It comes down to relentlessly testing with our athletes and continually questioning every step of the process. For example, an Aeolus carbon rim. Instead of drilling every spoke hole the same, we calculate the exact angle that the spoke is going to enter the rim. Lacing up the wheel, getting the nipples onto the spokes. We have specific tools that we have crafted ourselves that you just can't find anywhere else in the world. We check for hop and wobble, we check for tension, and then we move into dish to within 1/100th of a millimeter. To be able to manufacture something that precise, that's Wheelworks. We've got a lot of really talented and dedicated people who are committed to making sure that every wheel that leaves our door is deserving of your bike.
In 2010, we introduced the Speed concept to the world.
We felt like we had hit our big three parameters: best-in-class integration, best-in-class aerodynamics, and best-in-class fit.
The camtail technology that went into the current Speed concept was a huge revolution. I actually still remember sitting at my desk and first seeing that negative drag come up off the CFD simulation. And that was such an amazing moment that built into this bike that is still currently the fastest bike out there.
Going into the new bike, we said we have to give none of that up. And wherever we can, we have to improve on it, because we know we can always get better.
Instead of going to the drawing board, just kind of making something new for the sake of making it new, we leveraged that huge revolution and decided to take our design out of the wind tunnel and into the real world.
We really tried to put it into three key categories. You have aerodynamic performance, integration, and fit performance. When we started to look at developing a new Speed concept, everybody in the room agreed we needed to take it beyond the wind tunnel. We actually had to prove to ourselves and to our customers that we knew exactly what was happening out on the road.
We took our yaw and airspeed sensor out to the most extreme courses in the world, namely Arizona, which is sort of a low yaw angle course, and Ironman Hawaii, which is notoriously a high wind, high yaw angle course.
We discovered that you're looking at yaw in the 2.5 to 12.5 degree range, and that then became our focus on the project, is saying, let's make sure we absolutely win in that range.
The designing for these low yaw angles, we focused on things like frontal area, simplifying the front end, and improving the fork aerodynamics.
We didn't change our basic tunnel protocol with this new information on real world yaw. We still do a full sweep, we're still doing a full bike with and without a rider, with our pedaling mannequin. Some of the things that we assessed in the tunnel were variations on themes that had come out of our CFD work. Different shapes of frame gussets, refining the shape of the KVF tubing from the original Speed concept, because we knew we could improve on it.
So we took the new Speed concept not only to the wind tunnel for testing and validation, but we took it to the track with Fabian Cancellara. We tested both the current Speed concept that he was riding and his new Speed concept, and switching just from that bike to the new bike with the exact same position, we found him to save 30 to 40 seconds per hour.
Integration is really about systems, and in triathlon, the system is a really big deal. You have the rider's comfort, you have aerodynamics to deal with, and it really comes down to survival as well. So there's a lot of things you need to bring with you on a triathlon. Nutrition and hydration and repair kit.
These are the things real people carry with them. These are the things people hang on their bike, and you don't want them to be penalized for doing it.
If we work our way through the bicycle, if we start up at the front, we have a water bottle cage that's got a built-in computer mount on it, and then the speed box on top of the top tube's been redesigned. It's very clean and simple, very aerodynamic. The new draft box on the back of the seat tube is totally redesigned. It's a little bit bigger, you can fit tubulars in it easily now. It also has a quick release button. We also have a new 2-pack arrow. Basically it allows you to carry 2 bottles behind you as well as a bunch of supplies, and that actually makes your body faster.
The great thing about our storage solutions is that when you put them all on the bike, it actually makes you and the bike faster than if you use none at all.
We knew that our range needed to get a little lower than what we had before and a little further out in front. So we made sure that the new mono extension and the spacer system that goes underneath it could hit all of those points. The base bar now, not only by design, is located a little closer to the rider, but there's some adjustability there where you can bring it back or push it out a little further, a little closer. At the pads, we retained our vertical capability in 5mm increments, added another 30mm of width at the pads. We retained the general philosophy of our stem system. We said, let's make this pure stack and reach. So now the 6 stems move straight up and only straight out as you go through the 6 sizes.
Our dedication to enhancing our aerodynamic understanding, enhancing real-world testing, understanding exactly what athletes are doing out on the road, how they're interacting with their bikes, what kind of hydration, what kind of nutrition, what kind of storage is being put on their bikes, and then extending the fit window. Those are the key things that really move the speed concept in a new direction, making the fastest bike faster.
By now you know carbon fiber is commonplace in mountain bike racing, so we at Trek knew we had to create a higher standard. That's why we developed the Anvil Strike Test. The Anvil simulates rock and trail debris, 150 grams sent at 38 miles per hour, like sending a cue ball with a sharp edge into the frame at 38 miles per hour. This test is a descendant of the original Anvil strikes used by the aerospace industry to test structural integrity of airplanes. To show you what this means in the real world, we killed a coconut. We looked at our warranty claims, and an overwhelming majority of carbon returns were due to down tube damage. OCLV mountain is a process of building a stronger carbon frame structure. We use it in nearly every carbon mountain bike. It's the right material for the right application. It increases damage tolerance at areas susceptible to impact from trail debris without adding significant weight. To further protect the down tube, we added a polymer shield that keeps the frame fresh underneath. Perfect for single track and technical trail riders who encounter rock kick-up all the time. We test all of our mountain bikes in multiple ways to ensure their lifetime integrity. But we knew in order to build the world's best mountain bikes, we had to take it one step further. Let's start with a baseline. This is an aluminum frame. The anvil strikes the frame and creates a surface dent. After our intense testing, almost without fail, the frame becomes unrideable. Now, we test a standard carbon frame. The anvil hits the frame and it cracks. During our testing, these cracks spread, rendering the bike unrideable. This time, we tested our OCLV mountain. When the anvil strikes, the laminate shows distress, but after our stringent testing, the frame does not fail. The distress is only cosmetic, and the bike is as good as new. Now, with carbon armor, when the anvil strikes the OCLV mountain frame, the shield entirely absorbs the impact, keeping it fresh underneath. So while carbon armor is great for keeping your frame looking its best, OCLV mountain is the real technology behind stronger carbon that keeps your bike rolling through the toughest conditions. OCLV mountain is the right material for the right application. That's why you'll find race day bikes keeping their ultimate lightweight without carbon armor. OCLV mountain is stronger carbon, specifically engineered to keep your Trek mountain bike riding at its best for years to come. Trek mountain bikes with OCLV mountain are available at a Trek dealer near you.
Hi, I'm Dylan. I'm the guy who created ABP. Most full suspension bikes have an inherent drawback. The rear suspension actually firms up under braking. Who wants a bike that only works when you're off the brakes? But bikes with ABP are different. Active braking pivot lets your suspension work whether you're braking, pedaling, or coasting. ABP is active suspension all the time. Let's take a look at how the other guys do it. When designing rear suspension, you place a variety of pivots in different locations to let the wheel move up and down. Some people put the rear pivot above the axle, others put it below the axle. Unfortunately, the shock doesn't move freely under braking. Simply put, the braking forces actually cause the system to resist absorbing bumps. This means you end up skipping over the top of the bumps instead of tracking over them. And then there's ABP. Instead of putting the pivot above or below, we place the pivot in line with the axle. This placement is ideal because it lets the suspension function whether you're braking, pedaling, or coasting. Brakes on or off, the suspension moves up and down smoothly, absorbing all the bumps all the time. This makes your suspension more effective and makes your brakes work better too. So you can ride harder, brake later, and stay in control. The rear pivot and the wheel axle, all in line as a single unit. It doesn't require any special wheel, and it's 30% stiffer than any open dropout design. Watch as the single track gets choppy. The rider starts braking through the bumps, and the suspension stays completely active, absorbing every impact. Let's see that again. Watch his wheel. His brakes are engaged, and yet the wheel is still moving freely. Without ABP, he'd be skipping around. The suspension remains active and is able to absorb the impact. More control, better feel, higher cornering speed. That's the ABP difference. ABP is available on all Trek full suspension bikes. To experience ABP, test ride any Trek full suspension mountain bike at your local Trek dealer. Or to learn more, go to trekbikes.com.
I want to cover the earth with bikes, and I want happy people on bikes. And these are the guys that are going to do it. That's why I'm here.
There's a lot of really passionate people at Trek, and that's something that comes through when you see how much we put into the bike. There really is nothing like racing to help you improve a product or improve a bike. I think it's important to come with kind of an open mind and be ready to look and observe.
Design, engineering, and manufacturing are all very, very closely linked together. We tend to integrate everything, all the way from industrial design, all the way through fabrication, paint and graphics, you name it, out to the final customer.
I saw how much potential there was to really improve the ride quality and overall performance by making the suspension an integral part of the original design. That collective brain trust of all those experts coming together, you know, there's no egos, you know, and so on. Everyone's working for a common goal, and that's to produce the best mountain bike experience possible.
Wheel size, 26-inch, 650B, 29er. The mountain bike world is in flux. Some riders know what size wheel they want. In that case, no need to convince them otherwise. However, for all the people confused or wondering about all the wheel sizes, it's important that they hear a simple and consistent message about wheel size. For the longest time, 26-inch wheels were the popular option. Then the convention was blown up with 29er's popularity, and it even opened the door for yet another wheel size, 650B. Why does the mountain bike world need 3 wheel sizes? And how should we consistently sell them? First, a quick primer on the 3 wheel size options. 26-inch, the smaller wheel. The standard wheel size from the beginning of mountain biking is now the smallest diameter. It's the most flickable, most playful wheel size, and for those who like an active, nimble ride, 26-inch wheels are still a great choice. 650B, the new wheel size. Also commonly called 27.5-inch. However, 27.5-inch isn't accurate. 650B is closer to 26-inch wheels than 29-inch wheels. Not surprisingly, 650B rides and behaves much like a 26-inch wheel. 29-inch, the big fast wheel. It is noticeably larger than 26-inch or 650V wheels, and as such, it rides and behaves differently. 29-inch wheels preserve momentum, which gets interpreted as a faster wheel on the trail. They also inspire confidence and stability. So why do multiple wheel sizes even exist? It boils down to riding style. Different wheel sizes offer different rides. We've adopted the simple mantra, one trail, two riders. Different size wheels offer different riding characteristics. Larger wheels are faster and more confidence-inspiring, and smaller wheels seem more maneuverable and playful. Your riding style affects what size wheel you choose. Pick a bike with the right wheel size to match your riding style. There are also some common misconceptions about wheel size. They're important to dispel right away. 1. Rider height affects wheel size choice. That's simply not true. Wheel size does not affect bike fit. Frame geometry affects fit. Smaller riders can benefit from the advantage of bigger wheels, just as much taller riders might like a more lively 26-inch wheel bike. We've even had some very accomplished racers within Trek that are only 5'2" that have had their best race results on a 29er. Number 2, there is an ideal pairing of wheel size and suspension travel. Also, not true. Cross-country racers like the momentum of 29, downhillers still prefer the lively handling of 26-inch wheels. However, for the large number and variety of trail riders, any of the wheel size options will work. The rider needs to be paired to the right wheel size. So remember, riding style affects wheel size, not fit, not suspension travel. Which wheel size is right for me? Riding style determines which wheel size is right for any rider. Ask yourself and your customers the following questions to figure out which wheel size is right. Remember that 650B and 26 are very close in size and behave similarly, so they are grouped together as a single option. What ride quality do you want from your bike? With 650B and 26, it's playful, nimble. It's really just a fun, active ride on the trail. With 29er, you get a more confidence-inspiring ride that rolls over anything and has incredible traction. While riding, you like to focus on which? With a 650B or 26, terrain and technique, so that you can work the bike again to its advantage and have a good, playful, fun time on the trail. With 29er, you're focused on the pedaling and power efficiency you get from the bigger wheels to allow you to conquer the terrain more easily. When encountering trail obstacles, 650B and 26, you prefer to play with the trail and use the obstacles to your advantage. With 29er, you prefer to carry speed over obstacles, use the momentum of the wheels to carry you through the terrain and over these obstacles easily. Finally, remember that wheel size is only one variable on a mountain bike. A mountain bike is a combination of suspension, geometry, frame construction, drivetrain, component spec, and wheel size. Each matters. The best bike is the one that has the best integrated package of all these elements. Even when you've identified the ideal wheel size, it's still possible to find a bad bike due to substandard suspension or geometry design. Trek goes to great pains to deliver the best complete bike package on the market.